Hi, my name is Amar and I'm a PhD student in computer science in the University Carlos III de Madrid. It's my pleasure to present to you our paper called SoniWeight Shoes, Investigating Effects and Personalization of a Wearable Sound Device for Altering Body Perception and Behavior. In this work, we present a wearable device composed of binaural microphones, an equalizer, and a pair of headphones. We designed 3 filters that correspond to 3 different sound conditions: high frequency, low frequency, and control. The 3 filters are obtained amplifying or attenuating the corresponding frequency bands. When we hear someone approaching behind our backs, we are able to identify quite a lot of information about this person. For example, it's easy to discriminate between a female or a male body, as also its shoe size and posture. In general, heavier bodies are associated with sounds that have a lower frequency components compared to lighter bodies. When we consider individuals with clinical levels of symptomatology of eating disorders, we can see that they report distorted body perceptions. For example, anorexia nervosa patients exhibit altered motor behavior, such as the case of walking through door openings with shoulders rotated more widely than the shoulder width. For these individuals, there is also an increased plasticity of body perception during bodily illusion, and this suggests alterations in processing of bodily signals. Regarding physical activity and body perception, negative body perceptions predict physical inactivity that is one of the major critical health risks. Research in this field is being made, and sensory feedback techniques like the footstep illusion, and it's also worth mentioning that movement sonification is being explored with positive results in enhancing physical activity. Regarding societal impact of body concerns, we know that negative body perceptions are linked with various health conditions and affect motor, social, and emotional functions. Studies on gender perceptions and aspirations found a strong correlation of gender identity with changes in body perception. Sensory imagery, that is the capability to clearly imagine different sensations and objects, plays a role in body perception and motor function. The hypotheses of our study were 5, and while the main include variations of the effects of the different sound conditions with the levels of symptomatology of eating disorders, physical activity, and the image concerns, secondary hypotheses consider gender perceptions as influenced by sounds, and the same for gait patterns. Finally, we also hypothesized that effect of sound would vary with sensory vividness capabilities. We recruited participants using the university pool, flyers, and social networks. Of the 181 suitable participants that filled in the questionnaires, we have tested 84 people in a way in which we could form 4 equally sized groups with varying levels of SED and PA. For details regarding the choice of thresholds, please refer to the paper. The experiment procedure is detailed in the diagram. At the beginning of the experiment, as a baseline, the participants answered the questionnaire on body feelings and emotional experiences. Then the experimenter explained the trial to the participants, composed of a walking task of 10 meters for 6 times along a wooden runway. During the walking task, the Rococo suit and the Vitalino devices recorded physiological signals. After each trial, we repeated twice the body visualization, and finally, we conclude with the questionnaires and the filling of the body maps. This trial is repeated 6 times, 2 for each conditions, in a randomized order. Just for the sake of completeness, I will now describe to you the list of the measures we have acquired. That includes self-reports, gait cycle acquisitions, physiological signals, and body maps. Using a 27-inch screen positioned vertically, the avatar task consists of twice reaching the preferred body size on the screen using the keyboard arrows. The values were then read on the tool and recorded by the experimenter. Regarding the questionnaires, it is composed of several Likert scale items on some body perception items, additionally to arousal, balance, and dominance. The walking movement was captured using the Rococo mockup suit, and the sensors were attached to the participant's body, are illustrated in the central figure. They are essentially wired electrodes that capture EMG, ECG, EDA signals, and the respiration belt. In this slide, we can also see an example of a body map representing a front and a rear body silhouette in which participants marked the areas they felt more related to the effects of sound. I am also showing you some examples of physiological and acceleration signals. These signals were filtered according to literature, and many algorithms for feature extraction were employed. Let's move on to the results. In this table, I present to you the results of the questionnaires on body feelings and emotional experiences. As you can see, I marked the items in which the effect of sound condition is significant. The most important in this descendant order of effect size are weight, proprioception, quickness, masculinity, and surprise. As you can observe, the main differences are between the high and the low frequency conditions. Moreover, these graphs visually show the differences in the questionnaires items according to the three conditions. To summarize, people felt lighter, quicker, more feminine, happier, weaker, and more straight up in the high frequency condition compared to the low. Additionally, the body visualizer results transmit the same results. From gait analysis results, we can also see that people moved faster in the high frequency condition. And regarding ECG, the heartbeat is lower in HF compared to LF, and SDNN, that is a time domain measure of heart rate variability, HRV, is higher in HF compared to LF. We also analyzed hips and thorax movements and found a positive correlation between these movements, angle, and the femininity levels. We then analyzed the effects of sound conditions across the 4 different groups, and the graphs shows these main results. Regarding the SED groups, main differences are in the questionnaire answers. Specifically, for proprioception, we have higher values for low EDQ in LF compared to HF, while for the high EDQ group, we have higher proprioception in HF compared to LF. As for vividness and dominance, these items follow the opposite trend. Regarding PA groups, high levels of physical activity are associated with smaller variations between conditions for straightness and balance, and higher levels of arousal for all conditions. Regarding the other individual differences, I recall that we considered MBSRQ for the body image concerns, and for positive body image, we show an increase of hip flexion angle and mean velocity and perceived strength, and a reduction in heart rate and surprise for the high frequency condition. We also analyzed the effects on different levels of imagery vividness, and for higher imagery capabilities, the perceived weight increases for both modified sound conditions and hip flexion. EDA and heart rate decrease for the high frequency condition. The last results I'm showing to you are the body maps. 6 body maps were filled for each participant. To quantitatively analyze them, we overlapped a segmentation map on the body maps to count the regions that people marked. We summed up those regions and processed ANOVAs. For the significant regions, we then calculated the average for each of the sound conditions, and we used these values to represent the areas on the body maps. As you can see on the right, high-frequency condition involved mostly upper body parts, while low-frequency condition involved the lower. We also considered the effects of sound on the 4 different population groups. and we found quite different results in the areas in which people felt more effects of the sound modulation. As a general discussion, we can admit that we replicated the previous findings with low-frequency sound that increase body weight perception, masculinity, and reduce foot acceleration, and high-frequency sound that decrease body weight perception, increase femininity, happiness, and speed. Moreover, high frequency triggers physiological changes indicating positive emotional effects. High frequency is also associated with decreased heart rate and increased heart rate variability, indicators of relaxation and positive emotions. Regarding individual factors, eating disorders symptomatology influences sound feedback effects for dominance, perception, and EDA. Levels of physical activity affect body feelings and physiological responses for valence, arousal, and EDA. Body concerns play a role in shaping perception and physiological responses. We have effects for strength, surprise, and gait cycle. To conclude, we have some methodological reflections and contributions that are essentially the findings on individual factors influencing effects of footstep sounds, and the importance of a dataset that we have created that provides valuable insights for future analysis and comparisons. I would like to conclude with a call for personalization of sensory technologies, considering individual differences and to encourage exploration of individual factors in research and design endeavors. Thank you very much for your attention.